We've never found anything like the solar system. Part 2. What's out there? By far, the most numerous group of exoplanets is a class that isn't even represented in the solar system. That's the mini-Neptune, gas-enveloped exoplanets that are smaller than Neptune and larger than Earth in size. Most of the confirmed exoplanets are on much shorter orbits than Earth. In fact, more than half have orbits of less than 20 days. Most of the exoplanets we've found orbit solitary stars. Much like our Sun, fewer than 10% are in multi-star systems. Yet most of the stars in the Milky Way are members of a multi-star systems, with estimates as high as 80% seen in a partnership orbiting at least one other star. Think about that for a moment, though. Does that mean that exoplanets are more common around single stars, or that exoplanets are harder to detect around multiple stars? The presence of more than one source of light can distort or obscure the very similar, but much smaller, signals we're trying to detect from exoplanets. But it might also be reasoned that multi-star systems complicate planet formation in some way. And this brings us back home again, back to our solar system. As odd as home seems in the context of everything we've found, it might not be uncommon at all. I think it is fair enough to say that there's actually some very common types of planets that are missing from our solar system, says Bayliss. Super-Earths that look a little bit like Earth but have double the radius. We don't have anything like that. We don't have these mini-Neptunes. So I think it is fair enough to say that there are some very common planets that we don't see in our own solar system. Now, whether that makes our solar system rare or not, I think I wouldn't go that far. Because there could be a lot of other stars that have a solar system type set of planets that we just don't see yet. On the brink of discovery. The first exoplanets were discovered just 30 years ago orbiting a pulsar, a star completely unlike our own. Since then, the technology has improved out of sight. Now that scientists know what to look for, they can devise better and better ways to find them around a greater diversity of stars. And, as the technology advances, so too will our ability to find smaller and smaller worlds. This means that exoplanet science could be on the brink of discovering thousands of worlds hidden from our current view. As Horner points out, in astronomy, there are way more small things than big things. Red dwarf stars are a perfect example. They're the most common type of star in the Milky Way, and they're tiny, up to about half the mass of the Sun. They're so small and dim that we can't see them with the naked eye, yet they account for up to 75% of all stars in the galaxy. Right now, when it comes to statistically understanding exoplanets, we're operating with incomplete information, because there are types of worlds we just can't see. That is bound to change. I just have this nagging feeling that if you come back in 20 years' time, you'll look at those statements that mini-Neptunes are the most common kind of planets, with about as much skepticism as you'd look back at statements from the early 1990s that said you'd only get rocky planets next to the star, Horner tells Science Alert. Now, I could well be proved wrong. This is how science works. But my thinking is that when we get to the point that we can discover things that are Earth-sized and smaller, we'll find that there are more things that are Earth-sized and smaller than there are things that are Neptune-sized. And maybe we'll find that our oddball little planetary system, in all its quirks and wonders, isn't so alone in the cosmos after all. Published by ScienceAlert.com on December 29, 2022. By Michelle Starr.